Okay, continuing on with the next example, we're going to solve the polynomial equation like we've done before. And so we're going to go ahead and get this side equal to 0. And when I go ahead and do that, I'm going to subtract 4x on both sides. I want the negative 4x to be right before the 1. I want to make sure these terms are in order. So just make sure you do that. And then now I'm going to find the boundary points like I've done before. So I get 4x squared minus 4x plus 1 is equal to 0. I'm going to factor the left-hand side. The negative 2 times negative 2 is 4, and they add to negative 4. Well, our boundary points here, if I were to solve this equal to 0, the boundary point is going to be 1/2. And if I did it here, also, this would be 1/2 also. So boundary points are x equal 1/2. So I'll have one boundary point. And then I'm going to go ahead and just test these two intervals right here and here. So I'm going to test something less than 1/2, which would be 0. So I put 0 in the original inequality here. So I have 4 times 0 squared plus 1. Is that greater than or equal to 4 times 0? And I get 1 is greater than or equal to 0. That's true. And I'm going to test something on this side. So I'll test 1. So I get 4 times 1 squared plus 1. That greater than or equal to 4 times 1. And so I get 4 plus 1 that greater than or equal to 4. And that's true. It looks like it actually works in both intervals. So when I actually graph this, I'm actually going to shade in the entire number line. So my interval is going to be from negative infinity to negative infinity. That basically means that any number that I pick and I put in this inequality will be a true statement. Okay? Any number you pick in there. Okay, let's go to the next example. That's an interesting case there. Next example, we're going to have to do the same thing. We're going to solve the polynomial inequality. And it already has one side equals 0, so I'm going to go ahead and find the boundary points. Do 9x squared minus 6x plus 1 is equal to 0. Nine x squared minus 3x plus 1 equals 0. So 3x minus 1 equals 0 means my boundary point is going to be 1/3. I'm only going to have two intervals to test, this side and this side. So I'm going to test something less than 1/3, that'd be 0, be a great one. So I get 9 times 0 squared minus 6 times 0 plus 1, is that less than 0? So 0 minus 0 plus 1 is 1 less than 0, and that's no. I'm going to test something greater than 1/3. You can test at 1. The 9 times 1 squared minus 6 times 1 plus 1, is that greater than 0? This gives me 9 minus 6 plus 1, that greater than, or less than 0. I said the greater than, I meant less than 0. So 3 plus 1 is 4. Is 4 less than 0? And that's no. So when you graph the number line, or graph the solution in a number line, you wouldn't shade anything in. And so there'd be no solution. You can write no solution. Or you can use symbol, no solution. That means no value that you can pick. No value. There's no value of x that you could ever pick that would make this inequality, or this side of the inequality, less than 0. Okay, so those are two interesting cases. The last two examples I did, where you'd have all the numbers would work or none of the numbers would work.
Okay, at the end of the section, it's actually the end of chapter 3. So if you have any questions, make sure you email me.